Hello, my name is Rishan Joshua D'Silva, roll number 20AE10031. I'm a first year undergraduate student in the Department of Aerospace Engineering, and this is my video for the DIY assignment 2. The problem that I will be stating here is manual control of a bot using push buttons and proximity sensor. First, I'll be describing you the circuit that I have set up using the online software tinkercad. Uh, First, there are four push buttons that I'll be using each for a particular function. The first push button is for moving forward, second push button for backward motion, third push button for rotating the bot about its axis in the anti-clockwise direction, and the fourth push button for rotating it about its own axis in the clockwise direction. And there are two motors that will act as the wheels of the bot. These are connected to the Arduino using an via an H-bridge motor driver, that is L293D, and each of the motors are connected to the voltmeter to measure the voltage across it. And there's a, ultrasonic distance sensor HCSR04 that is connected to the Arduino. Okay, so now I'll be showing you the simulation of how it will work if it is connected to the computer for the given code that I will show you in the later in this video. When I press the first push button, uh, as you can see, the voltage across both the motors is 6.3 or 6.4 nearly, which shows that both have a positive uh, rotation so that the bot moves forward. And when I leave the push button, we can see the voltage across it goes to 0. And when I press the second push button, the voltage across them is reversed, but with the same uh, magnitude, so that now the bot moves backward with the same speed. As you can see, the uh, motors also have the RPM is also given, which is negative. And when I press the third push button, we can see motor 1 has a positive voltage and motor 2 has a negative voltage. This means that motor 1 moves with a positive RPM and motor 2 moves with the negative RPM, such that now the bot rotates in an anti-clockwise direction. And the voltage here is nearly halved by 2, so that during the rotation the speed is slower, and when I leave it goes to 0. And when I press the fourth push button, now it is the opposite. The second motor has a positive voltage and first motor has a negative voltage, so that now it moves in a clockwise direction. And now I will show you the function of the ultrasonic distance sensor. As you can see, this bluish green is circle is represents the obstacle. Whenever it is uh, as you can see, its distance is shown as 150.1 centimeter right now. Whenever its distance is above 100, the LED over here does not glow. So whenever I bring the obstacle closer to it, that is, if I bring it below 100, the LED glows, which alerts the user to stop the bot. So this is the simulation uh, as per the code that I have written. Now to show you, to explain the code that I have written, I have written it using blocks for easier understanding. So uh, the push buttons, they are connected to the digital pins 2, 3, 4, and 5, and as you can see using the blue wires, and the diagonal pins are connected to the this 5-volt line that is connected to the 5-volt pin of the Arduino, and the other pin is connected to the ground volt, such that whenever the push button is pressed, it is connected to the 5 volts, and the digital pin reads high. And if the push button is not pressed, it reads low, as it is connected to this ground line. So now first I will read, I have created an if-else statement. So in the if clause, I will read if digital pin 2 is reading high or low. If it reads high, the pin 6 and 9, that is the motors are connected to the pins, the motor 1 is connected to pin 6 and 9 via the H bridge motor driver L293D. It has input pins and output pins. The output pins are connected to the motor. The input pins are connected to the Arduino, that is pins 6 and 9. Uh, the enable pin of the L293D is connected to the 5-volt line, and the power pin is connected to the 9-volt battery. So, the same connection is done to the other motor, but the pins for the other motor are 10 and 11. The pins 6, 9, 10, and 11 are PWM pins, so that we can vary the voltage across it, so that uh, we can have a vast or diverse voltage across the motors. So whenever the pin 2 is high, I'll set the pin 6 as 200, and I will set the pin 6 as 200 and pin 6 as pin 9 as 0 and pin 10 as 200 and pin 11 as 0, such that terminal 1 will be high, terminal 2 will be 0, and same for the motor 2, terminal 1 will be high, terminal 2 will be 0, such that they have a positive rotation. Then if the push button 1 is not pressed, it will go to the push button 2. The same is checked, that is digital pin 3 is checked. If not, the same opposite of what the push button 1 has done, terminal 2 is set as high and terminal 1 is set as low. Same is done to the motor 2. And then push button 3 is checked, which is the digital pin 4. If the digital pin 4 is pressed, it sets this with the positive voltage 100 and 0. uh, Notice here that the number set is 100, which is lesser than the initial 200, so that it now rotates with a smaller velocity. And the motor 2, that is pin 10 and 11, are given a negative voltage, that is 0 and 100. So now even if the third push button is not pressed, it checks the fourth push button, which is digital pin 5, and now the motor 1 is given negative voltage and motor 2 is given positive voltage, so that it now rotates with a uh, clockwise direction. And then finally it comes to the else clause. If nothing is pressed, all the pins are set to 0, so that the motors have 0 voltage across it and it doesn't move. And then the final if else statement for the ultrasonic distance sensor, which is connected to pins 7 and 8, and it is checked if it is less than 100. If it is less than 100, the LED pin that is connected to pin 12 is set as high, and else if not, then it is set as low. So this is the code for uh, a code in blocks for the circuit that I have created. Now I will go to blocks plus text, which shows the C++ code for the given set of blocks. I will copy it and paste it in the Arduino IDE, and I will compile it. It shows done compiling, which means this is an error-free code. So now the code for the circuit is done, and we have come to the end of the video. Thank you for watching.